Hello everyone. Today we shall discuss about the multiplication of integers, right? Multiplication of a positive integer and a negative integer, right? That we know that multiplication of whole number is repeated addition. For example, 5 plus 5 plus 5 is equal to 3 into 5, that is 15, right? Can you represent addition of integers in the same way? Yes, we can represent addition of integers in the same way. Here we have found that minus 5 plus of minus 5 plus of minus 5, that can be written as 3 into minus 5, that is we are getting minus 15. That is it is a repeated addition, right? In the same way we can say that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer, right? Like this in the above. Now, here you see that in general for any two positive integers a and b, we can say that a into in bracket minus b is equal to minus a into b, that is equal to minus a into b. You have to remember this one, that is in general rule for any two positive integers a and b, we can say a into minus b is equal to minus a into b is equal to minus a into b. Multiplication of two negative integers, what you will find multiplying by two negative integers, right? Well, in general, for any two positive integers a and b, minus of a into minus of b is equal to a into b, and the sign will be positive because minus into minus we are getting plus sign, right? In this way, you can find the various multiplication of integers. Product of three or more negative integers. What you will find? Product of three or more negative integers. In the same case, if the number of negative integers is in a product is even, then the product is a positive integer. If the number of negative integers in a product is odd, then the product is a negative integer, right? Now properties of multiplication of integers. Multiplication, that is properties of integer multiplication of integers. Closure under multiplication. Here you see, if you multiply two integers minus 20 into minus 5, you are getting 100. That product is an integer. The product is also an integer. Here you see minus 15 into 17, we are getting minus 255. The product is an integer. Therefore, we can say that multiplication, that is a into b, is an integer for all integers a and b. What do you observe? That is, this gives an idea that the product of two integers again is an integer. So you can say that integers are closed under multiplication, right? Integers are closed under multiplication. That is, a into b is an integer for all integers a and b. Commutativity of multiplication. Commutativity means in general we can say that a into b is equal to b into a, right? For any two integers a and b, we can say that a into b is equal to b into a. Multiplication by 0. Multiplication by 0, we know that the whole number when multiplied by 0 gives 0. Observe the following product of negative integers and 0. These are obtained from the patterns done earlier. There is minus 3 into 0, 0, 0 into minus 4, 0, 5 into minus 5 into 0, that comes to 0, 0 into minus 6 equal to 0. This shows that product of a negative integer and 0 is always 0, right? In general, for any integer a into 0 or is equal to 0 into a is equal to 0. Multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. Check that 1 is the multiplicative identity for integers as well. Observe the following products of integers with 1. Minus 3 into 1, that is minus 3. Minus 4 into 1, that is minus 4. 1 into minus 5, that is minus 5. 1 into minus 6 is equal to minus 6. 1 into 5, 5. 1 into 8, 8. 3 into 1, 1. 5 into 1 is equal to 7. This shows that 1 is the multiplicative identity for integers. Also, in general, for any integer a, we have a into 1 is equal to 1 into a is equal to a, right? Therefore, you can say that 0 is the additive identity. 0 is the additive identity, and whereas 1 is the multiplicative identity for integers. We get additive inverse of an integer when a is multiplied with minus 1. That is, a into minus 1 is equal to minus 1 into a is equal to minus a, right? You have to remember this one, that 0 is the additive identity, whereas 1 is the multiplicative identity for integers, right? We get additive inverse of an integer when a is multiplied by minus 1. That is, a into minus 1 is equal to minus 1 into a is equal to minus a. Associativity of multiplication. Associativity of multiplication means in general for any three integers a, b and c in bracket a into b is equal into c is equal to a into in bracket b plus c. This is known as associativity of multiplication, right? Thus, like whole numbers, the product of three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers, right? Next one is distributive property. What is that distributive property? Here you can say minus 2 plus 3 plus 5. We can write minus 2 into 8 minus 2 into 3 plus 5, that is 8, equal to minus 16, right? And minus 2 into 3 plus minus 2 into 5, that is minus 6 plus of minus 10, that you are getting the same result, that is minus 16. This is distributivity distributivity of multiplication over addition, right? Distributivity of multiplication over addition, right? For any, in general, for any integers a and b and c, a into b plus c is equal to a into b plus a into c, right? This is the distributive property over addition, right? Here also you see that in general for any three integers a, b, c, a into b minus c is equal to a into b minus a into c, right? Making multiplication easier, we can make the multiplication easier by grouping the integers. That here you can say, here you will find that minus 25 into 37 into 4. We can group it as minus 27 into 37 is minus 925 into 4, this is minus 3700. We can do this in this way also, that is minus 25 into 4 into 37 minus 25 into 4, that is 100 into 37 minus 3700. This one is easier than that. By grouping them we can find the easiest method, right? Here we find also, that is n into 49 into 18, n into 25 into to find this one using distributive property. No need. These are the various properties we know. Now we will solve, in the next video, we'll solve the exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.